Welcome back, guys. Now in this video let's discuss about spermatogenesis as well as oogenesis. Now what exactly is happening in spermatogenesis? We are forming the gametes. Okay, we are forming the sex cells, male sex cells, the sperms. And oogenesis, we are going to form the ovum. Right? So now first let's begin our topic with spermatogenesis. Spermatogenesis. So sperm genesis, the birth of the sperms, right? So when spermatogenesis is going to start, before puberty or after puberty or intrauterine life? So spermatogenesis begins at puberty. Okay. Now what happens during puberty? What are the changes that are going to be seen during the puberty? Is the sex cords in the testis. Sex cords in the testis, they develop lumen. Okay, they develop the lumen. Now the same sex cords, after developing the lumen, they become seminiferous tubules. They become seminiferous tubules. Now within the seminiferous tubules, spermatogenesis is going to occur. In the seminiferous tubule lumen, spermatogenesis is happening, right? Now, how exactly spermatogenesis is happening? Okay, before going to discuss about that, you have to know some important points, some important terminology. So diploid cells. So diploid cells means they are having two sets of chromosome. It's represented with 2n. Okay, it's represented with the 2n. 2n here stands for 2 capital N or small n. You can take anything. Here 2n stands for a cell is having two sets of chromosome. Most of our body cells, they are diploid. Two sets of chromosomes, 23 chromosomes from father, 23 chromosomes from mother. Two sets of chromosomes are there. So if in a cell, if there are two sets of chromosomes, then we are going to call it as a diploid, 2n. So these diploid cells are going to convert into haploid cells during spermatogenesis. Okay, they becomes haploid cells, which means they become 1n. So this is the most important step. Okay, so this is what we want, right? So in our body cells, we are having 46 chromosomes. So the baby also have to have the 46 chromosomes, the next progeny also have to have the 46 chromosomes. So what happens is, so in a sperm, how many chromosomes are going to be there? Only 23 chromosomes are going to be there. Okay, 23 chromosomes are going to be there. Now when the sperm meets the ovum, okay, when it meets the ovum also have 23 chromosomes, 23x. Now the sperm with 23 chromosomes, either it can be X or Y. When it fuses with the ovum, so 23 and 23, it becomes 46. After fertilization, it becomes 46. But by themselves, sperms are having only 23 chromosomes, so they are 1n. And ovum, they are also having in the beginning, okay, in the beginning, oocytes, they are having only one set of chromosomes, 23. So they are haploid cells. Our germ cells are haploid. Okay, germ cells are haploid. So that's what I want you to know. So what is diploid and what is haploid? Okay. Having said that, now let's begin with spermatogenesis. What are the things which are happening in the spermatogenesis? See, the first cell that's going to be there, see, actually they are primordial cells. Okay, primordial germ cells which are derived from epiblast. Okay, they are derived from epiblast. Now these primordial germ cells, now they have migrated to the region called as the genital ridge. In the future, the genital ridge is going to become testis. So at the end of the day, the point which I want you to know is, in the testis, there are these primitive cells called as spermatogonia. So these spermatogonia are 2n. 2n means diploid. So these spermatogonia, they are continuously undergoing mitotic divisions. They are continuously going mitotic divisions. So they are maintaining their cell population. Okay, cell population. Now what happens is, see, they are undergoing mitotic divisions. So after undergoing mitotic divisions, what happens is, by the time of puberty, okay, by the time of puberty, what happens is, this spermatogonium, whatever is there, okay, see, this is the seminiferous tubule. In the seminiferous tubules, at the basal side, this side, whatever I am highlighting, this side is called as the basal side. In the basal side, there are these spermatogonia which are diploid. Okay, they are diploid. So they are undergoing mitotic divisions, okay, they are maintaining their cell population. Now, what they becomes is a primary spermatocyte. Okay, now you will have it out. Sir, what exactly is this primary spermatocyte? Is it haploid or diploid? Look here, this is also diploid, it is also 2n. But what is the difference is, see, the DNA is getting synthesized, the new DNA is getting synthesized. Previously chromosome is something like this. Okay, look here, concentrate here in this cell which I am pointing. See the DNA, it's having just like this, it's just like this. Okay, but now in the primary spermatocyte, DNA synthesis is happening, so new sister chromatids are coming. Okay, so that's the difference. Here, let me put it this way for easy understanding purpose. Yes, these cells are diploid. Okay, the cells are diploid. 2n, okay, 2n, but 2c, 2n, 2c. So the spermatogonia are 2n, 2c. But here, it is also diploid 2n, but 4c. 4c means 4 sister chromatids. 4 sister chromatids are there. Okay, you look here how they are. Now, later what happens? Now these cells during puberty, they will undergo mitotic divisions. They will enter into the mitotic divisions. During mitotic divisions, what happen? During mitotic division, the chromosomes are going to be separated. The 46 chromosomes becomes 23. So the number is getting reduced to half. So that's why, please look here, within the cells, there is only one set of chromosome, not two sets of chromosome. Previously in the primary spermatocyte, there are two sets of chromosome. So which means chromosome number 1 have two copies, one from mother, one from father. Two sets of chromosomes. But once the meiotic division, first meiosis division is completed, they becomes haploid. Now it is 1n. Okay, 1n. It is 1n, 2c. Okay, now inside the cell, you can see only one set of chromosome is there, so it is haploid 1n. But still, sister chromatids are there. Okay, sister chromatids are there. Two sister chromatids are there. Okay, so it's 1n, 2c. Later what happens is, guys, remember, what I am telling you is, again, let me give you a recap so that you will have a better understanding. First, primordial germ cells are going to be there. The primordial germ cells, they will enter into the testes. There, they become spermatogonia. The spermatogonia during puberty, they are going to convert into primary spermatocytes. The primary spermatocytes after meiosis 1, they become secondary spermatocytes. Okay, now they are secondary spermatocytes. What is the difference between primary spermatocyte and secondary spermatocyte? Primary spermatocyte is diploid, secondary spermatocyte is haploid. Okay, secondary spermatocyte is haploid. Now, this secondary spermatocytes, now they enters into the meiotic division, second meiotic division. Okay, second meiotic division. So, after this second meiotic division, what happens? Now, the cells are going to divide, each cell is going to divide into two cells. Look what happened. Still these cells are haploid 1n, but they are 1c. Okay, 1n, 1c. Which means what exactly happened is, for example, see, this is a secondary spermatocyte. Here I am showing the secondary spermatocyte, something like this. So this is how the secondary spermatocyte is. It is 1n, only one set of chromosome is there. It's the same chromosome. Okay, so how can we say it's a one chromosome or two chromosomes? Based on the number of centromeres. Okay, based on the number of centromeres. Okay, so it's the same 1n, it's a haploid cell. But 2c, two sister chromatids are there, this and this, two sister chromatids. Okay, 1 and 2c. So what happens is, this cell in meiosis 2, it's going to divide something like this, and it becomes, this is the primary spermatocyte. This is a primary spermatocyte. It's going to become secondary spermatocyte. It becomes like this. So it becomes 1n, 1c, 1n, 1c. Okay. So this is what is happening. So these are coming. So secondary spermatocytes are going to become spermatids. Secondary spermatocyte is becoming a spermatid. So again, recap. So what do we have? Epiblast. From the epiblast, primordial germ cells are derived. The primordial germ cells, they will go to a region called as genital ridge. In the future, the genital ridge is going to become testes. So in the testes, the primordial germ cells become spermatogonia. The spermatogonia during puberty, they becomes primary spermatocyte. The primary spermatocytes enters into the meiosis division 1. At the end of the meiosis, they becomes secondary spermatocytes. So secondary spermatocytes are haploid, but the primary spermatocytes are diploid. Primary spermatocytes are 2n, 2c. Okay, 2n, 2c, this one. Okay, sorry. Primary spermatocytes are 2n, 4c. The secondary spermatocytes are 1n, 2c. Okay, they are 1n, 2c. So, just, yeah, look here. Okay, so secondary spermatocytes are 1n, 2c. Now the secondary spermatocytes, they enter into meiosis 2. They enter into the meiosis 2, later they become 1N, 1C. So far what we have formed? We have formed something called as spermatids. The process of conversion of, the spermatids to a mature sperm, this process is called as spermiogenesis. Let's write important points directly. Primary spermatocytes. Primary spermatocytes. Primary spermatocytes are what? They are 2N, 4C. Let me show you again. Most of the students will get confused here. Say, look, primary spermatocyte, they are still not, they haven't entered into the meiosis, so they are still 2N. They are still 2N, but 4C, this one. This is a primary spermatocyte which have synthesized the DNA. See this one. Sorry, I got little confused. So this one. Its primary spermatocyte is 2N, 4C. Now, in the cells, DNA synthesis completed. They will enter into meiosis 1. Enters meiosis 1. Now, secondary spermatocytes. So, secondary spermatocytes completes meiosis 1. Completed. They start to enter into, meiosis 2. They start meiosis 2. At the end of the meiosis 2, they become, the secondary spermatocytes. The secondary spermatocytes, look here. The secondary spermatocytes, they become 1N, 2C. 1 and 2C. They already become haploid, but still they are having their sister chromatids. So 1N, 2C. So at the end, what should happen? The spermatids, whatever were there, the spermatids which are haploid, 1N, 1C, they need to be converted into the sperms. So that process is called as spermiogenesis. Spermiogenesis. So what is happening during spermiogenesis? What are the changes that are going to occur during the spermiogenesis? The sperms develop something called as a cap. There is sperm cap which is called as an acrosome. Acrosome is going to develop. There is development of acrosome which contains the enzymes which are necessary for the process of fertilization. Next, there is condensation of nucleus in the sperm. Condensation of the nucleus in the sperm, and there is formation of neck and tail. There is formation of neck and tail for the sperms. So these are the changes which are going to occur during the spermiogenesis. So spermiogenesis is formation of a sperm from spermatid. Formation of a sperm from spermatid. Now, what else I have to teach you regarding the spermatogenesis is there are certain cells which are assisting this process. For example, look here, there is a Sertoli cell. There is a Sertoli cell. These cells, these cells which are present over here, all these are the Sertoli cells. See this total yellow color cell. The total yellow cell which I am showing here, which I have shown here in the that yellow color, that's a Sertoli cells. See what the Sertoli cells are forming. Let me write here one by one. Sertoli cells. These Sertoli cells, they lines the walls of wall of seminiferous tubule. They are within the seminiferous tubule. They are inside the lumen of the seminiferous tubule. They lines the wall of seminiferous tubule. So what is their function? They nourish. They are like a nurse. They are nursing cells. They are nursing cells. They give nourishment to sperms. What they do? They nourish the sperms. They regulate spermatogenesis. Now these Sertoli cells, they are under the control of which hormone? The Sertoli cells are under the control of FSH. FSH. So FSH is going to stimulate the Sertoli cells. So Sertoli cells regulate the process of spermatogenesis. Not only that, these Sertoli cells, they actually form a lining. In between the Sertoli cells, there are going to be tight junctions. Okay, tight junctions. So these Sertoli cells actually form blood testicular barrier. It forms blood testicular barrier, okay, which doesn't allow any toxic substances from the blood to enter into the testis. So Sertoli cells are totally taking care about the spermatogenesis process, okay. And not only that, the LH is going to act on the Leydig cells, okay, Leydig cells. The Leydig cells produce something called as testosterone. This testosterone also assists the process of spermatogenesis. So, for the process of spermatogenesis, you require the FSH, LH, Sertoli cells, Leydig cells, okay, all these things you have to know. Now, after this, let's discuss about oogenesis, okay. Before going to the oogenesis, again I want you to know some important points. First, spermatogonia is going to be there. That spermatogonia will be converted into primary spermatocytes. Primary spermatocyte enters into the meiosis 1, becomes secondary spermatocytes. Secondary spermatocytes enters into meiosis 2, becomes spermatid. The spermatids have to convert into sperms. That process is called as spermiogenesis. For your exam, what they will ask you is spermatogonia. Okay, right, let me write here. Spermatogonia. Okay, spermatogonia. Primary spermatocytes. Secondary spermatocytes and spermatids. Okay, so what are the differences? See, spermatogonium is diploid, primary spermatocyte is also diploid, but secondary spermatocytes are haploid, spermatids are also haploid, and even sperms are also haploid, all are haploid. Sperms are having 1N, 1C, spermatids also having 1N, 1C. Secondary spermatocytes, they are 1N, 2C. Primary spermatocytes, they are 2N, 4C, 2N, 4C. Okay, there is a DNA synthesis, but spermatogonia are 2N, 2C. Let me draw the images. Small diagram. Look here. Spermatogonium. How it is going to look like? Spermatogonium, it is having two sets of chromosomes. Like this. Okay. So, two sets of chromosomes are there. 2N. Okay. Two sister chromatids are there. Like 2. So, 2N, 2C. Done. Next, primary spermatocytes. So, what's happening in the primary spermatocytes? Still, two sets of chromosomes. One set from mother, one set from father. But they have undergone DNA synthesis. Okay, DNA replication. So, DNA synthesis. So, something like this. So, 2N, 4C. Okay, 1, 2, 3, 4. Okay, 4. Next, in secondary spermatocyte, what happens? In secondary spermatocyte, see, meiosis 1 is completed. Now, it becomes secondary spermatocyte. In secondary spermatocyte, you are going to have a structure something like this. Okay, it becomes 1N, but 2C. Okay, 1N, 2C. In spermatid, what do you have? In spermatid, the structure is going to be something like this. It is 1N, 1C. Okay, in the sperm also. Okay, in the sperm also, what do you have? One set of chromosome. Okay, only one set of chromosome. 23 chromosomes will be there, one set of chromosomes. So they are haploid 1N, 1C. Okay, so these are the points which I want you to know for your exam. Next, let's discuss about the process of oogenesis. Okay, now let's discuss about the process of oogenesis. See, what is different between spermatogenesis and oogenesis is that spermatogenesis begins at the puberty, but oogenesis begins during intrauterine life. So, begins in intrauterine life. So, in a female, when she is at a stage of like a fetus, she is having ovaries, and in that ovaries already oogenesis have begun. Okay. Now, let's see what are the important points which I want you to know. See, here are oogonia. Okay, just like Spermatogonia, there are Oogonia. These Oogonia are continuously undergoing mitosis and they are maintaining their population. See, 2n, 2n, 2n. Now this Oogonia, just like Spermatogonia, what happens? This Oogonia, they enters into, okay, meiosis 1. This Oogonia are entering into meiosis 1. Once they enter into the meiosis 1, they becomes primary spermatocyte. They becomes primary spermatocyte. But the problem is, see, this primary spermatocytes, they have entered into the meiosis 1. But this meiosis 1 is arrested. Okay, there is arrest. In the prophase 1 of meiosis 1, in the prophase 1 of meiosis 1, the oocytes are arrested. Okay, the oocytes are arrested. Meiosis 1 is not completed. So, a female who is in the intrauterine life, there is a female who is still in the womb of the mother. Now, in this female, in the ovaries of this female, oogenesis have already started. Now, this oogonia, they have entered. Okay, the oogonia, they becomes like the oogonia. Look, the oogonia, they enters into the meiosis 1, primary oocytes, and they are arrested. Okay, they are arrested in prophase 1 of meiosis 1. Now, when it is going to be completed? When it is going to be completed? During puberty. So, during puberty, the meiosis 1 is completed. Once it is completed, once the meiosis 1 is completed, you are going to have the secondary oocyte, just like spermatogenesis. Okay, just like spermatogenesis. Primary spermatocyte enters into meiosis 1 over there. Here also, in meiosis 1, you have the primary oocyte. Primary oocyte is now entering into the meiosis 1. Primary oocyte is entering into the meiosis 1, no doubt. Now, the primary oocyte, after the completion of meiosis 1, it becomes secondary oocyte. Two cells are going to come. One cell is dividing, means two cells are going to come. So, you are going to have one secondary oocyte along with first polar body. Okay, first polar body which is useless. Now, what happens? Same. So, after the completion of first meiosis, okay, after the completion of first meiosis, the diploid cells are becoming haploid. Okay, diploid cells are becoming haploid. Okay. Next, this secondary oocyte, they begins meiosis 2. Okay, they becomes meiosis, they enters into the meiosis 2 and again they are arrested. Again they are arrested in the meiosis 2. Where they are arrested? In metaphase 1. In metaphase 1, they are arrested. Now, when they are going to complete this metaphase 1 after fertilization, or I should say, when they are going to complete this meiosis 2 and when they will form this ovum, when they are going to form this ovum, okay, after fertilization. Okay, after fertilization. For easy understanding purpose, let's write something like this. First, you are going to have a oogonia. Here is a oogonia. Now, I am summing it up. Oogonia. Okay. Now, this oogonia, it is diploid. So, two sets of chromosomes are going to be there. Two sets of chromosomes, oogonia. So, it is 2n, 2c. This oogonia, they are undergoing mitosis, many number of mitosis, okay. During intrauterine life only, okay, during intrauterine life only, this oogonia, they becomes primary oocyte. So, what is the difference between oogonia and primary oocyte is this, DNA synthesis. So, now they becomes 2n, 4c, 2n, 4c. Now, this primary oocyte have entered into meiosis 1. Meiosis 1, it have entered into the meiosis 1. After entering into the meiosis 1, you are going to have, see, meiosis 1 entered but arrested in prophase 1. So, in prophase 1 of meiosis 1, these primary oocytes are arrested. Done. Now, when this meiosis 1 is going to be completed, this meiosis 1 is completed. Okay, completed by puberty. So, till puberty they are arrested. So, what happens during puberty? The cell is going to complete the meiosis 1 and becomes like this. Cells are going to become haploid. The cells are becoming haploid. So, they are becoming 1n, 2c. 1n, 2c. So, 1 will become primary, 1 will become first polar body. Okay, this is the secondary oocyte. Now we are having the secondary oocyte, which is 1 and 2 side, 2 This secondary oocyte, it enters meiosis 2. Okay, it enters meiosis 2, but again it is arrested where? In metaphase 1. In metaphase 1 of meiosis 2, it is arrested. Okay, it is arrested. When it is going to complete its meiosis 2? After fertilization. After fertilization, it is going to complete its meiosis 2. Once the sperm is going to penetrate, once the sperm penetrates this secondary oocyte, okay, secondary oocyte, this is the keyword. Once the sperm penetrates the secondary oocyte, then only it's going to complete its meiosis 2. So, it's going to divide into something like this. Okay, this one cell, okay, one is gone. Okay, this becomes the polar body and it's gone. Now, this cell is going to become something like this. Okay, so it becomes 1N, 1C, and this will become second polar body. Okay, so when do you have first polar body formation? First polar body formation is seen during the puberty. The second polar body formation is going to be seen during fertilization. Fertilization. So the second polar body is useless. It's going to be gone. It's gone. This is your ovum. Okay, this is your ovum. That is 1N, 1C. Okay, sperm is going to bring one more set of chromosomes. See, sperm is coming like this. For example, if I show sperm like this, sperm is also going to have one set of chromosome, right? So when these two cells, when the sperm and ovum, when they fuse, sperm is also 1N, 1C. When both sperm and ovum fuses, the resultant zygote, that's going to be something like this. Okay, now it becomes diploid, 2N, 2C. Diploid. Again, you are going to get the diploid state. This cell is going to divide and forms a new individual. So, in this video, what we have discussed is complete spermatogenesis and oogenesis. Again, as a recap, spermatogenesis coming from spermatogonium. Start from the spermatogonium. Spermatogonium going to form the primary spermatocyte. Primary spermatocyte enters into the meiosis 1, becomes secondary spermatocyte. Secondary spermatocyte enters into the meiosis 2. At the end of the meiosis 2, you are going to have the spermatids. The spermatids are going to become sperms by the process called as spermiogenesis. And little different is about the oogenesis. Oogonia, they are dividing by mitosis. The oogonia becomes primary oocyte. They becomes primary oocyte. The primary oocyte enters into the meiosis 1, but it is getting arrested at prophase 1. During puberty, the prophase 1 is going to be resumed. The meiosis 1 is going to be resumed and meiosis 1 is completed. Now, what you are going to have is called as the secondary oocyte. Now, the secondary oocyte enters into the meiosis 2, but it is arrested at metaphase 1. The meiosis 2 is going to be completed only after fertilization. After fertilization, the secondary oocyte is going to divide into one polar body and ovum. That's it. Okay. So, these are the important points which I want you to know regarding spermatogenesis as well as oogenesis. Hope the video is helpful. Thank you.